Well, again, welcome to the end of this semester. We have covered all content that we need for Calc 2. So now it's just basically a matter of reviewing and prepping for the final. Today, I'm going to go over a few things. I'm going to talk a lot about final prep and things that you can do. And essentially, from this point until the final, it's like one big set of office hours. I will not be doing any form of lecturing, but I will definitely be answering questions and guide you. To simply do problems now isn't really very useful because you need to come up with the questions, having gone over stuff in practice. So I want to start by going over the last quiz to make sure that we're all doing the same thing. So the problem starts this way. Now, there is no direct translation into rectangular when you just have a sine or you just have a cosine. The things you're looking for to translate into rectangular, you're looking for r squareds, r cos thetas, and r sine thetas. Those are the three things you're looking for. This would be an x, that would be a y, that would be an x squared plus y squared. If you see something like that in polar, then that's the easy translation. I have none of those, but you notice if I multiplied both sides by r, I would have all of those. So we talked about this last week. Is it legal to multiply both sides by r? Because if r equals 0 isn't a solution to this original problem, then multiplying both sides by r will completely change what the graph would be. So you got to be really careful. Let me give you an example. We know that cosine and sine only range between -1 and 1. Okay, so with that said, we get a pretty extreme range of values here. We could go, plus or minus 8 for this guy. We could go plus or minus 6 for this guy, and then every combination. So we sense that r equals 0 is probably in there somewhere. But what if I had 8 cos minus 6 sine, plus 1,000? There's no angle where that r would ever be 0. So for me to multiply both sides by r would completely change what that thing is. It would not be the same thing anymore. And all conclusions from that point on would be invalid. Yikes. So the question is, can this r ever be 0? Well, if 8 cos theta were to equal 6 sine theta, that would make r equal to 0. Well, let's see if I manipulate this. And let me move the cosine that way and the 6 this way. So 8 over 6 or 4/3 equaling sine over cosine. Oh, so if 4/3 equals the tangent of theta, which is definitely okay. I mean, it's going to happen when theta is the inverse tangent of 4/3. Oh, okay. There is definitely at least one angle that would make this true, meaning there is an angle out there where this quantity is 0, meaning r equals 0 is already a possibility. Another way of thinking about that is this graph passes through the origin. If this graph did not pass through the origin, then I cannot multiply both sides by r. I'd have to find another way. So that what I'm just showing you, most people don't do. It's usually not in the textbooks, but it is absolutely critical because we would be basically changing the foundation of the problem. So I'm going to multiply both sides by r. And when I do that, the left side will be r squared, the right side will be 8r cos theta minus 6r sine theta. And now my substitutions are easy and hopefully obvious. Now on the left side, I have x squared plus y squared. On the right side, I have 8x minus 6y. Now, if you didn't already do this problem, I mean, you've already done this problem. What is this? Can anybody tell me what this is? Just what was the first thing you had in mind when you got this far? Anybody?
A circle?
It's a circle. Well, what do these guys do? Well, it just shifts where the center is. If there was no x and y, then I'd probably center it at the origin. Oh, but these guys are going to shift me left and right. And we saw that in the rotation of axes. Only the squared terms determine what the shape is. The other terms determine where the shape is. So for me to figure out, I need to complete the square. So we're going to do x squared minus 8 squared or 8x plus y squared plus 6y, and all of that is equal to 0. Now let's go ahead and complete the square. Okay, so remember the rule, half of that number, and then I want to add the square of that number. So I'm going to add that to both sides. Half of that number, and then I'm going to add the square of that number to both sides. So I have x minus 4 quantity squared plus y plus 3 quantity squared equals 25. So in words, all right, Lisa already told us it's a circle, but we could be much more specific now. It's a circle. By the way, with a circle, there's only two things that matter, right? The radius and the center. And you can tell me both. It's a circle with center what?
4, -3.
4, -3, because it's always x minus the x coordinate, y minus y coordinate. And the radius?
5.
5. I wonder if I drew that, what that would look like. Oh, let's do that. I don't need you to draw that. But it would be nice to confirm that I actually have interpreted this correctly. So I'm going to draw my circle of radius 5. We said the center was at 4, -3, which would mean if the circle's radius 5, okay, then 4 units over would mean that it's 5 from here to here. So that would mean the y-axis must pass kind of like that. Okay, everybody can see that? We said this is 4, -3, but that means that this is 3 units below the x-axis. So the x-axis must actually be doing something like that. I know that this is what the circle looks like. 4, -3, but what else do I know? I know because the radius is 5. You can do a quick check. 0, 0 to 4, -3 does have a distance of exactly 5. Plus, remember when we started, we determined that r equals 0 was a viable solution. So I've just proved that our circle actually does pass through the origin. Now, I don't need you to draw this, but it would be really good to know that that circle that we started with looks exactly like this, passes through the origin, that center, that radius. It's kind of cool. So I took the polar, translated to rectangular. If I had gone from rectangular to polar, I would have done essentially all the work in reverse. Okay, so that's that one. Now for the second one, we're going the other way. Okay, the second problem, we started with something in rectangular. And now we're going to go polar. Now, what is this graph, anyone?
Hyperbola.
Yeah, it's a sideways opening hyperbola, so I'm not going to get quite so lucky. Now, there's a few different things I can do, but basically, I'm going to substitute x and y in the same manner. In other words, x is still r cos, y is still r sine, so that part doesn't change. So what I want to do is figure out exactly how to do this. So one thing I can do is I can multiply both sides by a common denominator. Okay, I believe 144. 16 goes into 144, 36 goes into 144. By the way, I don't have to do this. This just makes it easier. I don't have as much action going on. I don't like the quotients when I'm doing this. All right, so this would be 9x squared minus, I'm sorry, 9x squared minus 4y squared equals 144. Now, if I substitute r cos and r sine, this becomes 9 times r cos theta quantity squared minus 4 times r sine theta quantity squared equals 144. So this would be 9r squared minus 4r squared minus sine theta. Now, generally speaking, when you put something in polar, you always want to write it in the form r equals function of theta, kind of like the first problem was. The problem is I have an r squared. If I had the equation of a circle with x squared plus y squared, we could solve for y squared, but we can't solve directly for y because that would mean we'd have a plus or minus and all that. So at the very least, I can get the r squared by itself. So if I write this as r squared times 9 cos squared theta minus 4 sine squared theta equals 144, then I can say clearly r squared equals. Now, at this point, all of you should want to do something with that. is there any Pythagorean identities I can employ here? Any double angle formulas? Is there anything that I can do to make this way cooler, way simpler, way cleaner, or just would it just be different? You want to try that one?
Isn't it's equal to cosine 2 theta on the bottom, although cosine squared minus sine squared?
Problem is the coefficients are different though.
Yeah.
The cos squared minus sine squared is cos 2 theta. So if I had the same coefficients, clearly I could factor that out. And by the way, I would do that in a heartbeat, because if I could write the denominator as constant times the cosine of 2 theta, then I could bring it up and call it a secant 2 theta and life would be good. The problem is because of the different coefficients. Now, some of you say, well, can I use a Pythagorean identity and change everything to sine squared? Yes, then I'd have a constant minus sine squared. Or I could change the sine squareds to cos squareds. Then I'd have cos squared minus constant. But like I said before, is it an improvement or is it just a different representation? In this case, it would just be a different representation. I don't think it would be an improvement. Can I write R equals? Well, got to be careful. This quantity right here can be negative, and that's a problem, isn't it? So how could this quantity be negative? Well, if theta was pi over 2, I'd be negative. Oh, so I am definitely limited. That bottom quantity can't be negative because this is an R squared. Oh, but also it's a hyperbola. So I'm better off leaving it. If I write R equals, and then I try to manipulate the square root, I could say something that's not correct. So probably best to just walk away from this one as is, because there's certain things I don't want to have happen. You know, we're not excited about this answer, but it's what it is. Now, the next one is going to involve a little bit of calculus. So now we're going to take a derivative. And by the way, any version that you wrote here that's correct, if you changed it all to cos squares or you changed it all to sine squared, if you manipulate that, if you decide to add and subtract and get a double and a single angle, that's not wrong. It's just not better. So I would tend to leave it alone. If it's not an improvement, don't make it more complicated.
Professor, taking the square root then is just not quite right. Not quite what you want to do.
Because then you'd say R equal plus or minus.
Oh, right.
Yeah, that's the problem.
Okay.
And by the way, is that wrong? No, but it's not better. Let's put it that way.
Okay.
And then you start running the risk. Well, what if I don't write the negative? Did I just, by the way, if you wrote R equals and you only wrote the positive square root, you'd say, I'm okay with that, but I'll give you a hint. You just eliminated exactly half the graph. It is a hyperbola, remember. Hyperbola is not a function. So hyperbolas are just evil enough that's not one that we dwell on. We don't. We like circles with polar. We don't really like hyperbolas, but that I'm just showing you an example of the manipulation. So now I got R equal 2 cos theta, and I have theta is pi over 3. Now, we've looked at this one before. So I kind of want to answer the question before we actually start the problem. I want you to think about this. We know that R equal cos theta is what graph? Do you remember? We did this one. R equal to cosine is very specifically what? Without you doing any work. Did you remember what it was? Both R equal sine and R equal cosine are the graphs of, I'll give you a hint, they're round. Circles. Yeah. R equal cosine is a graph of a circle that's on the x-axis. R equal sine is a graph of a circle that's on the y-axis, but also passes through the origin. So this graph here, I'm going to draw this fairly accurately. See, I cheat. I don't draw the axes and then try to fit the circle, and I draw the circle and then fit the axes in. This graph right here. Now, if theta were 0, I'd be at 2 units. So this right here is a circle of radius 1 centered at the point 1, 0. If you said, how do I know that? Well, first of all, if theta is pi over 2, I'm at 0. So R equals 0 is a solution. So if I multiply both sides by R, I'm going to show you, we've done this problem before. Then this would be x squared plus y squared is 2x. So x squared minus 2x plus y squared is 0. X squared minus 2x plus 1 plus y squared is 1. So x minus 1 squared plus y squared equals 1. This is how I would get it in rectangular. Circle of radius 1 centered at 1 comma 0. Okay. Why am I pointing that out? Because you can now look at the question, which was, what is the slope of the tangent line when theta is pi over 3? Well, if this is theta is 0, this would be theta equal pi over 4. So theta equal pi over 3 would be a little bit taller, you know, and so on. And then theta equal pi over 2 would be here. So pi over 3, I don't know how accurate I can draw this, but I'll do my best. Theta equal pi over 3 would probably be something like, I don't know, maybe like that. This would be my, I'll do it like this. Theta equal pi over 3 is actually a line with slope tangent pi over 3. So this point right here, again, don't go by the incredibly brilliant accuracy of my picture. I did freehand all of this just now. I'm trying to find the slope of that tangent line. Okay, that's what the question is asking. If I drew a perfect graph, you'd say, yeah, that slope, it doesn't look very steep, but it does look positive. Agreed? And it's not horizontal. That slope does look positive, and that slope is not horizontal. So if I want to figure out, okay, how do, you know, I want to do this. So I'm going to go back to here and now use my derivative formula. I drew this so you'd again understand what we're finding. So when we get an answer at the end, you can say, yep, that answer makes perfect sense. That's exactly what I was expecting. So let me erase this. So when we do the derivative from polar, remember, the only thing we actually need is the dr d theta. Dr d theta would be -2 sine theta. So with that said, then when I find my dy dx, okay, right here. So dy dx. Okay, so remember the order of things. So I'm going to take r, okay, and yeah, r times the cosine. So there's my r times the cosine. Okay, and then to that I'm going to add the sine times the derivative. Okay, then on the bottom I'm going to take my negative sine times the derivative, and to that I will add oh, I'm sorry. I just wrote that down. Negative. Sorry, I wrote the wrong thing. I can't read my own writing. Sorry. We're going to negative sine times r. I bet. Negative sine times r. I wrote the wrong piece. And then from there, plus cosine times the derivative. Boy, that was almost a disaster there. So when I'm looking at that, yeah. Now, how far you simplify it is not that critical, because the question says evaluate this answer at pi over 3. So right now I could evaluate this. I could put the pi over 3 in now. Why maybe is that not a great idea? Anybody? Why is evaluating this at pi over 3 now maybe not a great idea?
Is it because you have to add things and?
No, because I have 8 thetas.
Oh, okay. The obvious answer.
I'm being really, really lazy and really obvious. If I evaluate it now, that means I have to evaluate it in 8 places. And I don't know about you, but I don't really want to do 8 calculations. And by the way, I think 7 out of 8 on a test is considered pretty good. But if I get 7 out of 8 here, I have a completely wrong answer. So I think it might be easier to simplify this first and then evaluate it. You can evaluate it right now. But boy, that would be nightmares, because remember, you got quotients with roots in them in pretty much every term. So my numerator is 2 cos squared theta minus 2 sine squared theta. My denominator is -4 sine theta cos theta. And I'm writing in this form because hopefully now it's a little more obvious. If I factor and cancel a 2, it might even be more obvious. In fact, I'll put the negative out. Let me do it like this. I want this to be absolute easy peasy. What is my numerator? heard someone say it earlier, cos squared theta minus sine squared theta is
Cosine 2 theta.
cosine 2 theta. And again, I would rather do that because it's less work. But by the way, don't do that if you're not absolutely certain. So it's cosine of 2 theta on top. What is it on the bottom?
Is that sine 2 theta?
That's sine 2 theta. Oh my goodness. The gift that keeps giving. And I can go right with that, or I can go one step further. That's cotangent 2 theta. Now, a lot of you go, I'd probably rather just leave it like that. But again, cotangent's just the reciprocal of tangent. So that's not the worst thing. This is dy dx. So this would be the derivative on the xy plane, but in polar terms. So now what we want to do is I want dy dx. I'm not evaluating this, I'm evaluating this. I want dy dx evaluated when theta is pi over 3, and that would be negative cotan 2 pi over 3. Now, if it helps you, think of it in terms of tangent. The tangent of a 60-degree angle is just root 3. So the cotangent of a 60-degree angle is the reciprocal of that, root 3 over 3. This is in the second quadrant, so it's going to be negative. Okay. The cotangent part's going to be negative, but then I got the negative in front. So think of this as the negative of root 3 over 3. Again, the tangent of 2 pi over 3 would be a root 3. The cotangent would be root 3 over 3 with the negative. So my final answer, when all is said and done, is just that. By the way, we would have gotten that had we plugged it into here. Here's why you didn't want to do that. Because this would be a half, that'd be a half, root 3 over 2, root 3 over 2, root 3 over 2, a half, root 3 over 2, and then you'd be simplifying and yeah, you didn't want to go there. just way too nasty. It would be correct. Here, or you could have done it here, you could have done it here, you could have done it here. All of these would be easier than here because there are fewer thetas. And that's really what you'd be using to govern your decision there. All right. Now the bonus I know everybody's intrigued by. And to me, that is the most important problem on the quiz because that's the one that encompasses the most skills. And you don't have to be clever. You just have to know what it is you're doing and then follow it till the bitter end. So let's see, the bonus was, it's down here. So what do we have? We have r equals 6 minus 6 sine theta. And I said that theta is between. Now, why would this be necessary or why would this even be relevant? Anybody want to try that one? Because that actually is important, this part here.
Because it's a bound for the theta, the answers. Like you need
bounds, but why not 0 to 3 pi, or why not pi to 2 pi, or why not 0 to pi over 2? I mean, what is, when you're thinking of thetas, you're thinking of sines and cosines, and you see 0 to 2 pi, what's the first thing you think of? That you've kind of what?
Because 2 pi will get you the entire graph.
Because 0 to 2 pi is going to get you the entire graph probably. Now, we've seen situations where 0 to 2 pi actually repeated the graph. That's not the case in here because this is one of those cardioids. But the 0 to 2 pi means I'm going to complete the graph. If I only went 0 to pi, you should suspect that you only have a half a graph, but you're not sure which half. If it was pi over 2 to 3 pi over 2, things like that, you like that because there's less in doubt. Now, what this looks like, and again, I'm draw the picture because I think it's useful because when we get an answer, we want to know that answer makes some sense. Now, we know it's a cardioid, but because it's a sine and not a cosine, it's going to be a vertical cardioid. If it were cosine, it'd be a horizontal cardioid. So I'm going to give you a really rough sketch. Okay, when theta is 0, I am 6 units out. Let's say that, which way do I want to call? Yeah, I'll say that's 6. I got to make sure I have room on this. When theta is at pi over 2, I'm at 0. When theta is pi, I'm again 6 units out. And when theta is 3 pi over 2, that'd be 6 plus 6. So I'd be down here. That means this thing looks like this. This is kind of smooth. Okay, it's not perfect, but you got the idea. This is what it looks like. How do I know? Well, I know it's a cardioid. I know it's opening vertically, but I didn't even use that. I just took the 0, the pi over 2, and the 3 pi over 2 and plotted the points. And then because I know it's a cardioid. Now the question asks, let's see, what is the question? Where is the tangent line horizontal? Where is the tangent line vertical? Now, I'm not going to guess the angles, but I think it's fair to say that here, 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 that does not come to a sharp point. That's a curve. Where is it vertical? Somewhere around here, somewhere around here. And would you agree that right there, something truly interesting is happening? What is that point? We discovered this last week. What is that point? What's the word? Say again?
Cusp.
Yeah, that's a cusp. So a cusp really is neither vertical nor horizontal, but it's just weird enough to be cool. Remember that from Calc 1. That's a cool point. So what we want to do is we want to do the same derivative we just did a moment ago, but this time we want to figure out exactly where's the numerator 0, where's the denominator 0. And we suspect we're going to get a whole lot of answers here. So now I'm debating, should I leave my graph up there? I don't know if I have room to leave my graph up there. So let me go ahead and walk through it. So my slope, and I'll write M this time. My slope is, okay, first of all, what's dr d theta? Dr d theta is, -6 cosine. Okay. So is everybody cool with that? My dr d theta is -6 cosine. So what should I have then? So it should be R. Okay. Times cosine plus sine times the derivative. Sorry, this is going to be a little bit squished. And on the bottom, it's going to be the negative of R. I'll write it like this. Last time I wrote negative sine, but I'll write it in that form. And then plus cosine. Again, times that guy. All right. Now we got some major simplification that we need to do here. Let's see. Does anything combine or cancel? I'm not sure if anything's going to combine or cancel, but let's see what we get. On the top, it looks like I'm going to get, if I distribute here, let's see, 6 cos minus 6 sine cos minus 6 sine cos. Ugh, okay, a little squished. On the bottom, -6 sine theta plus 6 sine squared theta minus 6 cos squared theta. Now at this point here, do you all agree that we can get rid of some 6s? Obviously, every single term has a 6 in it.
Professor, I think the second term in the numerator should be, is it -6 sine cos?
What did I, on this one?
No, in the simplified version, the second term in the numerator,
Oh,
right there.
Oh, thank you. Thank you, Lisa. Yeah, that would have, when I started simplifying, that would have not gone so well. Thank you for catching that. I'm making the mistake. I want to leave this up. I probably shouldn't. I wanted to leave it up there so when we get an answer, we've already got it. I just don't feel like rewriting. I probably should erase it and rewrite it smaller. So now on the top, I'm going to get rid of all the 6s. So on the top, I now have cos theta, but there's 2 of them here. Agreed? -6 cos, -6 cos. So when I get rid of that, I'm going to have -2 sine theta cos theta, because right now it technically be 12. On the bottom, I'm going to have negative sine theta, and then here plus sine squared theta minus cos squared theta. Okay, so right now, that's what I got right now. Can I improve upon this? Well, you see double angle formulas, don't you? You see them all over the place, which would be perfect if I was going to evaluate it but actually in this case, I don't want to use the double angle formulas. I'm trying to figure out where the numerator equals 0. So I want to factor it. Yes, that is absolutely right there. That is sine of 2 theta. But let's suppose, just for a moment, my numerator, let's suppose I wrote my numerator like this. Okay, and now I want to know where's my numerator equal to 0. Does everybody see a problem with this? It's not possible to solve that problem because my angles are different. Oh, so in the previous example, we simplified everything and wrote everything as 2 thetas. We simplified it because we were going to evaluate it at a very specific angle. So we just wanted the smallest possible thing. Here, I'm not doing that. I'm not evaluating this anywhere. I'm asking where the numerator is 0. So I kind of need to leave it in this form and then factor it. Does that make sense, everybody? So I have a different goal in mind. Now, the numerator is easy to factor. The denominator, we have a problem, don't we? I can't factor the denominator because I got the cos squared. But can I change the cos squared so that it's all signs on the bottom? Yeah. If I replace cos squared with 1 minus sine squared, then my denominator will be this. That's my new denominator. So that would be 2 sine squared theta minus sine theta minus 1. And that turns out to be easy to factor. Okay. I'll rewrite this. Sorry. I just don't think I can squeeze everything in here. So right now we're going to factor our numerator and factor our denominator. So in my numerator, clearly I can factor out a cosine theta. And that leaves me with what? 1 minus 2 sine theta. My denominator, this is going to be 2 sine theta, sine theta. So let's see, I need that to be a minus, so that would be minus plus. Everybody see that? Nice simple factorization. So my denominator, 2 sine theta plus 1 sine theta minus 1. Now I had 2 goals in this problem. I needed to know where the numerator equaled 0. I needed to know where the denominator equaled 0. Okay, so I'm going to erase this because we don't need this anymore. That's what we need right there. And by the way, that 0 to 2 pi was actually quite important because that did allow me to complete the picture, as someone said. So let's start with the numerator. All right, I need cos theta equals 0, and I need 1 minus 2 sine theta to equal 0. Well, let's see. When is the cosine equal to 0? And the easiest way to do this usually is just think of a unit circle. Okay. When is the cosine 0? Well, here and here. So that would be at theta. And by the way, remember 0 to 2 pi. So I'm only going to give angles between 0 and 2 pi. I'm not going to do the plus k2 pi kind of thing because we just want the ones between 0 and 2 pi. So I want pi over 2 and 3 pi over 2. Well, that was easy enough. 1 minus 2 sine theta equals 0. That means that sine theta equals a half. Sine theta will equal a half here and here. Okay, that's a 30-degree type in both. So this would be theta equals pi over 6 and 11 pi over 6. So right now my numerator is going to be 0 at 4 different places. And then we'll go back to our picture in a moment to figure out what that looks like. This isn't my cardioid. This is just my unit circle to make it easier for me to answer that part. Now let's look at the denominator. We'll do that in black. So I need that quantity and the other quantity, sine theta minus 1. Well, in the first case, if 2 sine theta is 1, that means that sine theta is negative a half. So sine theta will be negative a half here and here. So that would be, that's pi, that's an extra 30 degrees. So that would be 7 pi over 6 and 11 pi over 6. hold on a second, this is not right. This is not 11 pi over 6. What should this one be? I just looked at that. Ah,
5 pi over 6,
5
I
pi.
think.
Yeah, I'm going, wait a minute, that was in the top half. Yeah, that would have messed us up. Okay, and then here, sine theta minus 1 equals 0. That means sine theta equals 1. Well, sine theta is equal to 1 here. So that would be theta is pi over 2. Okay, beautiful. Does anybody notice anything suspicious here? You should see one thing suspicious and one thing only. The numerator, we're asking the slope. This is the slope at every point on there. This is the slope of the tangent line at every point on the graph. We said the numerator will be 0. That means horizontal tangents at these 4 places. The denominator will be 0. That means vertical tangents at these 3 places. There should be something that jumps off at you as being suspicious at the very least. See these 4, see these 3. Come on, guys. What seems to be out of place? One of these things is not
Pi
like the other. Which one?
pi over 2.
Pi over 2. Why?
I don't know. I just see it in the numerator and
Because it showed up in both. Wait a minute. I can't have a horizontal tangent and a vertical tangent at the same place at the same time. Where do you suppose that one ends up? Where do you suppose that is? Because we only had one really cool point, remember?
The cusp?
The cusp. It turns out that's the cusp. And that's how we actually know that's the cusp, because of the weirditude. So now let's go back to our picture. We've answered the question, but now we want to go back to the picture to make sure our answer makes sense to us. Okay, that's ish. You guys get the point here. All right. Pi over 6. 7 pi over 6. Yeah, again, don't go by the accuracy of my drawing. Or I'm sorry, 5 pi over 6. And what about 3 pi over 2? Those are my 3 horizontal tangents. I have 2 vertical tangents. Seven pi over 6, 11 pi over 6. Again, even my crude drawing still agrees. But pi over 2, I have a cusp. A cusp, something weird was happening. It sure seems like we should have a vertical tangent. Actually, what's happening is at the cusp, my numerator and denominator are 0. That's an indeterminate form. Oh, cool. Now, normally we'd say removable discontinuity, but this is the derivative. The removable discontinuity in the derivative caused the cusp. There was no removable discontinuity in the original function. So that's kind of a cool thing. So we just analyzed this thing all over the place. Okay. So that's some pretty major stuff. We were able to get through that. Now, at this point here, we've done everything, and there's a little bit of calculus of polar coordinates. Next day, your quiz is going to involve areas, and it's not complicated. In fact, the integration itself should be relatively simple. It's all about setting up the proper integral. So that's a major question. Now, the one concern a lot of folks have anytime you have material at the end of a course is how heavily that material is weighted on the final. I mean, we've all had that course where your last exam was a few weeks before the final, and then all the last material presented before the final, turns out the entire final exam was mostly that stuff. Well, that's not a final exam. A final exam is cumulative. That's the definition. And so if we weighted this more than everything else we did in the course, then that's not really a true final. We've had 25 lectures. So a simple way to think about this, now this is not exactly what's happening, but it's actually not too far off. We've had 25 lectures. If we went back and said, let's take one thing from each lecture, what would we determine as the single most important conclusion or concept we learned in that lecture? You know, some lectures we did more than one thing, but what if we could do one thing in each lecture? Now that's a final exam question, but only one per class, not 3 questions from this class, none from those 2 classes. No, that's not a good final. The final, everything we did should be represented fairly, and so on. So 23 of your lectures were on the first 3 tests. You have 2 quizzes at the end, today and Monday, so that when you walk into the final, every single question on that final you have already done on a quiz, on an exam, or both. Okay. Only the polar stuff at the end didn't show up on an exam, but you will at least have had quizzes. So there's no mystery material. There are no questions where you say, well, we never went over that one, or we never did this. You'll say, oh, that's straight out of quiz 25. Now, it doesn't mean that you're going to have more questions at the end. It's going to be the same as everything else. So right off the bat, what is the most effective way to prepare? We have 1 week left, and in a perfect world, you started preparing weeks ago, just leisurely, going back over things and so on. But with 7 days remaining, if you had to prioritize, if you have time, I always say start with the exams. Retake your exams, retake the practice tests. That's why I make the detailed keys and I post them. I don't do that out of convenience for me. It's not, trust me. I do that so you can retake material. We all know that in preparation for an exam, retaking all of your quizzes is a great idea because you don't remember the answers you did, 3 weeks ago, 4 weeks ago. Heck, with exams, nobody remembers their answers from exam 1. You barely remember your answers from Monday's test, I'm sure. So retaking stuff and then grading yourself for 2 reasons. If you got it right the first time, do you still remember how to do it? That's the most important thing. And if you missed it the first time, have you figured out how to do it? So when you're redoing stuff, don't do it with the original answers in front of you, because that's going to kind of taint how you answer it. Sit down, retake exam 1, grade yourself, and then pull out your first test and say, did I get better? Did I get worse? Have I maintained? The most important thing is how you prepare, assuming you have a limited amount of time. Yes, you can retake all the quizzes as well, but you start running out of time to get through all this stuff, because I've heard rumors that some of you actually have other classes, might even have jobs or families. And as much as I'd like to believe you're going to spend every waking moment on this class, that may not be realistic. Now, I want to give you some simple advice. Some of you who were in my Calc 1 class, and you've probably heard me say this before, I've been doing this for a really long time. And my experience is that very few, if any, students I've ever taught in my entire life have even the slightest concept of how to prepare for a final. I've given well over 10,000 finals. And I can honestly say, I don't think I've ever had a student without me guiding them that would have prepared correctly. I hear this all the time. I studied for so many hours, fill in the blank, some absurd number of hours, and I still bombed the final. I don't understand why. Well, it's because they wasted every moment they spent. You see, the moment you tell me you are studying for the final, I already know it's going to be all wasted time. What does studying imply? That you're still trying to what? Learn. I'm sorry, but that's done. You can't try to learn the material between now and the final. I'm going to give it really simple. If in 4 months there are concepts that you've just not been able to get for whatever reason, is it reasonable to think you can teach it to yourself between now and the final? Because if you can teach it to yourself between now and the final, that means it probably isn't very complicated. It's probably low level if you could just teach it to yourself. But if that's true, then you would have taught it to yourself over the last 4 months. See, there are concepts that you just might have to write off and say, you know what, maybe not this semester. And it might not matter because you're going to have more questions than you have to do. And if there's a concept you just say, I just never got this one. Okay, move on. It's not a big deal. But people try to study for finals. My experience is that left to your own devices, most everybody here is going to spend 100% of their time trying to learn the things they never got. And you know how many of those you're going to get? Generally, none. It's just simple logic that no, you're not going to teach yourself anything you've never seen or never been able to do. Problem is, if you got it right in the past, you have to get it right on the final, because that means you know it, but you may have forgotten it. So what I tell people to do is retake the exams. And if you got it right before and you missed it, that means you forgot how to do it. It's still in there somewhere, but that means you've got to go back and review. So you don't study for a final, you review for a final. So I'm going to ask you a simple question. Let's say that you as an individual, you're about 80% in this course. I mean, all the quizzes, all the exams, you're pretty consistent. Your overall average was around, let's say 80%. And you had time. You started early. Maybe you started during spring break. You started reviewing. You started going back over old tests. And in other words, you felt totally prepared for that final. Then what would be sort of the upper limit of expectation? Remember, you got 80% all the way through the semester, and you had ample time to prepare. What would be a good upper limit for that person on the final? Anybody want to guess? It's actually quite simple. Only one possible number. What is it? Take a chance.
An A?
Nope, 80%.
A B?
80%.
Okay.
The highest you can possibly expect on the final exam is what you knew all semester. In other words, an 80% final for a person who did 80% all semester would be absolutely off the charts incredible. That means they remembered every single thing they learned. That's actually extremely unusual. I've been doing this for a long time, and I started keeping track even when I was teaching high school. From sophomore year in high school, I don't count freshmen, through college, and I've talked to people at UCSD, at San Diego State, and everybody has the same experience. The average performance on a final exam in a math course, the average performance, I'm talking thousands and thousands and thousands of them, is the same in every single class. It's about a 9 to 10% drop over the semester performance. In other words, a 1-letter grade drop on the final is the norm. That is the average performance. So the A student writing a B final, the B student writing a C final, that's sort of the expectation. If you wrote a final that was the same level as what you performed, that's considered outstanding because it means you remembered everything. Nobody really does ever remember everything. Now, can you actually improve? Absolutely. Because if you had ample time to review everything, and I think this would be safe to say of anybody who didn't get 100% on an exam, when you go back and retake things, a lot of things during the course of the semester that you missed, if you go back and retake them, there's a lot of things that you will get right because you have figured it out since then. You said, oh, after I missed it, I made the point of making sure I understood that concept, and then you got it right. That's where the improvement comes in. In other words, you first review everything to make sure that you have the solid base. If you got it right at any point in the semester, you've got to get it right on the final, because that means you do know it. It's a terrible thing when people have a lousy final because they just didn't get around to reviewing. Oh, I got 100% on exam 1. I don't need to review it. Actually, that's the one you should spend the most time on, because you have to get all of those right on the final, because there are problems that you did on exam 1. By the way, when's the last time someone did a partial fractions decomposition, a trig substitution, heck, even an integration by parts? You're like, oh yeah, it's been about 3 months. You might have been perfect on that day, but you haven't done one since. There's no reason to think that you're just going to remember everything the day of the final. So that's why you got to go back and review to make sure that that base is up to snuff. If there are things that you don't get, it happens. I just hope that's not a long list, because again, I'm going to ask you more questions than you have to do. So if you look at one, go, you know, I know how to do that one, but that one takes me longer, and we put it off. Just make sure you do enough questions. Okay, because on the final exam, I only like to ask what I call the big ticket items. Okay, not detail, not minutia. I'm not going to ask you, you know, here's an equation, what's the conic? And you say, well, AC, you know, minus this, right? That's like 8 seconds from beginning to end. No, but I'm going to ask you to do stuff like, well, maybe not quite this extensive, but like the problems on today's quiz, you know, what's the slope of the tangent line at this value? You know, because that required a little bit of effort, a little bit of work. So now the next thing is formulas, because I just got asked this morning. Can you reuse your formula cards? Yes, but no. Yes, you can, but don't. Why? Why don't? Anybody want to try that one? What was the point of the formulas? Was
The
it
process writing the formula card was meant to
Writing.
reinforce what you need to know. Yeah.
That's exactly it. By the way, most of you never actually look at them. You have them there. It's kind of like a pacifier. You have them there to suck on, you know, make you feel good. It was the creation, not the existence, as I say, of the formula card. It's the process of making it. You're forcing yourself to review everything you deemed important. If you simply reuse the old ones, then you will not get that review. And then you're sitting at the test, flipping over formula cards going, well, where is it? Oh gosh, I don't even know if I wrote that down. No, start over. This time you may use one side of an 8.5 by 11. The area of 3 formula cards, if you used every single square inch, is 90 square inches. The area on one sheet of paper is a little bit more than that. So it's a little bit more area, but because it's one side, it will actually be easier for you to organize things and you won't be flipping things over. But you want to start over because there are things that you put on the first 3 cards that you may deem unnecessary. You go, you know what? I know that one. I don't need to write it down. And if you're like most human beings, you forgot it may be 1 or 2 things per test. These I need to make sure that one gets on the final one. right? There may be things that you should have written down and you just didn't. Okay, so that's what you want to do. Now, it's a little difficult in this environment, but in a regular semester, I've always had people compare. You know, I say, why don't you guys compare formula cards, or in this case, formula sheets? Because, you know, James makes the greatest one in the history of formula sheets, and so did Lisi. And then when you compare it, I guarantee you, both of you will have one that the other one forgot. That always happens. And so when you do that, you go, oh, shoot, I didn't even think of that one. And or wait a minute, I wrote it down, but you had a different version. Oh boy, I wonder if I wrote it down correctly. I cannot edit your cards for correctness. So if you write down a formula incorrectly, and some people did on this last exam, they wrote down certain really easy formulas, but they wrote them down incorrectly, and that causes wrong conclusions. That's a bummer, but that's, you know, that's on you to make sure that you write it down exactly correctly, because in the process of writing it down, you reinforce the things you need to know. And of course, cheap calculator, and you need a cheap calculator because there's a little bit of calculating, not a lot, but you know, if there's a factorial involved, or if there's just simply, we had a Taylor polynomial where you had to evaluate. It wasn't a big deal, but you'd be amazed at how many people have a wrong numerical answer. They wrote everything correct, and then when they plugged in their numbers, they have a wrong number at the end of the problem. But all I needed to do was enter some things into a calculator. Yeah. And we still have incorrect numbers. We had great calculus, bad arithmetic. So make sure you have something that you're comfortable with. My favorite is this one. I don't own stock in it, but I probably should. The simple, this is the Casio, what is it? I don't know what it's called, but it's everything is a main function. The combination, permutation keys, factorial keys, fraction key, everything is a main function. There's no menu options to go to. So when I'm doing quick calculations, I have a you know, titanium, as most of you know, my TI-89. I don't use it for calculations. I use it for graphing. I use the cheap one for calculations. It's way, way faster, way simpler to navigate through. And if you don't have a simple calculator that you can trust, yeah, don't get one the day of. I mean, that's a bad idea. You know, are you going to need a calculator for this test? Minimally. But there is arithmetic, and I'd rather you not make mistakes on the arithmetic. You know, you got the perfect calculus, bad arithmetic, bad answer. So if the calculus is perfect, I want the answer to be perfect because you're almost there anyway. Now, right now, okay, the grades haven't been posted. I will have them up in a few hours. I'm fairly far along these exams. I will post the grades. By the way, I'm going to be a little behind on the quizzes, obviously, because I'm making the exams the priority. I had 30 question discrete math tests that I gave Monday morning. So I finished those, oh boy, yesterday around noon probably, and got their updates. And then I started ours, and I'm about 3/4 of the way through ours. I'll have ours done today, but then I got to start the calc ones I gave yesterday. So sometime by the weekend, I will get to all the quizzes. And I'm pointing that out because when you go to Canvas and you hover the cursor over your total, that's the key. That's the magic number. Whatever the threshold is for an A, B, and a C, I don't know the exact number off the top of my head, but it's actually, I probably figured out. See, it's 2550. Okay, so if you have 2,295 points before the final, you've already got an A. Okay, that's the threshold for an A. And it's on your syllabus. 2,040 is the threshold for a B. If you've reached that before the final, you're guaranteed that grade. So then you say, well, what if I haven't reached it? Well, what if you're 30 or 40 points, 50 points away from that with 2 quizzes left? You can still reach the threshold based on your last quizzes. That's why I want to make sure everybody turns in their last quizzes, okay? Because then you can go over the top. What if you're still not enough? Well, now you're saying, okay, what do I have to do on the final exam to secure the grade I want? Now, this is easy. When all the grades are posted, go to Canvas, find your lowest quizzes and your lowest exam. If the final exam exceeds your lowest exam and 5 lowest quizzes, then the final will replace them. If it doesn't exceed them, then the final is your drop score. It basically never happened. So if you drop your lowest exam score and 5 lowest quizzes and say, okay, this is exactly how many points now I need to reach the threshold, and that's how many points you're going to need on the final exam. It's actually that simple. It's not complicated, but I can't tell you, you just got to go to Canvas because everybody's got a different number, but you're going to have to wait until I post the exam to know how close you are. And it's reasonable that probably the majority of you will have secured an A, B, or a C. That's normal. My Calc 3 I think only 3 people hadn't secured an A, B, or a C. In my discrete math that I just gave, I think it was like 5 people hadn't guaranteed an A, B, or a C. In this class, that's similar, that most of you will be above that threshold, but then you want to know, okay, what do I need to do to get the higher grade? If it's reasonable that you can raise your grade by having a good final, then please take the final. If, let's say, you're at 79.8% right now, and those last 2 quizzes, they put you over the hump and now you're guaranteed to be in the class. Well, you're about a bazillion miles from the A, and you know that. So to get an A is probably not realistic. I mean, unless you get a perfect score on the final or something. So at that point, you can say, yeah, I will take my B and run with it. If you got an A, you can say, yeah, I'll take my A and run with it. I assume that every single person is taking the final unless you tell me otherwise. So if you are happy with the grade you have, and again, you'll know this afternoon, just send me a simple email and say, I will not be taking the final. But here's the problem some of us have. We'll say, well, I'm going to wait over the weekend and see how it goes. And then maybe on Monday, I'll decide if I'm going to take the final or not. I guarantee you, you're not going to take the final if that's you, because that means Monday has rolled around and you haven't started preparing for the final and it's 48 hours later. No, you already need to be knee deep in your final prep at this point. I need you guys, if you're going to take the final, commit now. Now, if you're on the fence because you're waiting for those quizzes, be safe. Say, no, I'm going to plan as if I am going to take the final, and then be pleasantly surprised if it turns out I don't have to. Because the flip side is people say, well, I don't think I'm going to take the final. And then next week they realize, oh, I didn't do nearly as well in the exam as I thought I did. Now I have to take the final, but I haven't started preparing. Yikes. Yeah, don't put yourself in that position. Okay, so what the remainder of today is, we're not even going to bother taking a break. I'm just going to go straight into office hours. If you have questions, Monday is just straight up office hours. Just come if you have questions. And a lot of you like to listen to other people's questions. That's fine. Some of you say, you know what? I can email you over the weekend and get my questions answered. That's fine. I'm still going to be here. I'm still going to be here Monday morning. So if you have questions, please come Monday and ask your questions. And there's no limit to how many. There's no lecture. Again, what I'll do on Monday is I'll go over the quiz again, because the last quizzes, it's the last material presented. You've had less time to absorb it. So that's why I don't mind going over it in a bit of detail like this one here. I don't usually do that because the key is good enough. So let me stop.